How fast does an area change? This is a visual approach to the product rule in calculus. If your area is length times width, that's a product. And if it changes, that means you're going to have a new length and a new width. The length is going to change by delta L. The width is going to change by delta W. So how much did the area change? The change in area is made out of three pieces. You could cut it like this and this. This piece is length times change in width. This piece is width times change in length. And this piece is change in length times change in width. Now, if we imagine this happening over time, then the rate at which this happens, we would need to divide by delta t. As you let the time interval get smaller and smaller, the limit is the instantaneous value, which is what we think of when we think of the derivative. So the rate of change right at that moment is the derivative. Now this takes a specific amount of time, delta t, and when we divide by delta t, we get this expression. If we imagine the delta t getting shorter and shorter, then instead of talking about average velocity, we talk about instantaneous velocity. Instead of delta L over delta t, it eventually becomes dL over dt. That's calculus. Likewise, delta W over delta t becomes dW over dt, which is W prime because we know all the derivatives are with respect to t, and so there's no confusion. We can just say derivative is prime. All right, well, if we put that in, that means we get area prime is equal to length times width prime plus width times length prime. But if delta L went to 0 and this thing went to derivative, we got 0 times the derivative, so that's gone. And we have the product rule.